Hey class, Miss Anderson here, factoring day 1, starting out unit 3 with some factoring. Unit 3 is all about quadratics and complex numbers. So today we're going to look at factoring where we have a leading coefficient of 1. So we're going to factor equations that look like this: ax squared plus bx plus c. And today we're going to focus on where a equals 1, and then we are going to look at a couple special cases. So our leading coefficient is going to be 1. So I don't know if you guys remember, if you learned the box method to multiplying. So if we multiply like the quantity x plus 3 times the quantity of x plus 5, we can use the box to help us organize that. It is a 2 by 2, so I can make a 2 by 2 box. Put my terms on the outside, so x and positive 3, x and 5, and then multiply corresponding positions. So like x times x is x squared, x times 3 is 3x, 5 times x is 5x, and 3 times 5 is 15. And then combining like terms, you'd get an x squared, 3x plus 5x is 8x, and then plus 15. So the box is just another way of multiplying this out. You might have also learned the method of FOIL. So first, x squared outside, that's the 5x, inside the 3x, and then last is the 15. So it's just another way of organizing, multiplying it out. Well, factoring is the reverse of multiplying. So we're going backwards. And so to factor, you can either set it up with the parentheses and say, okay, to get x squared, I need x times x. And then I need my last two. So, I look at the first and the last. I need the last two numbers to multiply to a 15. If I have to multiply to a 15, I can do, 1 times 15, 3 times 5, or that's about it. And I need them to add up to 8. So my only choices here are positive 3 and positive 5. So reversing it. If you use the box method to go backwards, you start by you put x squared here and you put the 15 here. And then you say, okay, what do I multiply to get to x squared, or what do I multiply to make the 8 in the middle? And I get the 3 and the 5, and I put those in, 3x and 5x, either position, doesn't matter. And then you work your way out, like finding the outside of the box. So, x times x had to be x squared, and then x times 3 was 3x, and x times 5 was 5x. So then my factors are the x plus 3 and x plus 5. So the box is just another way to organize that factoring problem. Factoring is a challenging concept because it's requiring you to think in reverse of multiplying, which can be challenging. So the box is a good way to organize those thoughts. So I'll do a combination. When a equals 1, it's easier to factor, and the box really isn't as necessary. But tomorrow when we look at when your leading coefficient of a is not 1, then the box is going to be really a good method. So I would say when a is equal to 1, so these are the easier factoring cases because it's just x squared. You know it's going to be x times x in your factors. So really all you have to figure out is what's going to multiply to this n number, multiply to b, but add up to, or multiply to c, but add up to the middle number of negative 10. So if you're multiplying to a positive 9, but it adds up to a negative number, that means both your factors had to have been negative, because two negatives will make a positive 9, like negative 1 times negative 9, or negative 3 times negative 3. These combinations will multiply back to positive 9, but they will add up to a negative sum in the middle, which is what you need. And in fact, it will be negative 1 and negative 9. So we can always check to make sure this works. So the first one is going to be x squared. And the last terms are giving you the 9. So really all you have to check is the middle. So x times negative 9 would be negative 9x. And negative 1 times x would be negative x. And if you added those together, you would get the negative 10x in the middle. So that is our answer. The next one is x squared. Again, so we know it's going to be x times x. This time we need it to multiply up to positive 8, but add up to positive 6 in the middle. So you have factors of 1 and 8, 2 and 4, 4 and 2. So I want positive 6 and positive 8. So this one works, x plus 2 and x plus 4. I'm going to get x squared on the beginning and 8 on the end. And then in the middle, I get a 4x and then a 2x, which makes the 6x in the middle. So these product of this binomial terms, the x plus 2 times x plus 4, if you had multiplied that back out, I would get that quadratic equation, x squared plus 6x plus 8. This is what we're practicing today. So here are the patterns. If you have this is B and this is C. If your C is positive on the end and it adds up to a positive in the middle, that means that both your factors were positive, plus and plus. It multiplies to a positive number in the end and it adds up to a positive number in the inside. The other case, when B is negative and C is positive, well, that means that to get the positive number at the end, your signs had to be the same, but they had to be both negative this time because the B is adding up to a negative number. So that one will be x minus and x minus. So when you multiply it out, you're going to get a positive answer at the end, the last one that you multiply, but in the middle, it will add up to something negative. And then you have the other two cases. If B is positive but C is negative, you're going to need one positive factor and one negative factor. But because they multiply to a negative number at the end, so you need one positive and one negative. But if they are adding up to a positive number, then the larger one has to be your positive factor, because when you add them up, your answer in the middle is positive. And then the same thing, if B is negative and C is negative, then you have one of each. But this time, the last factor is going to be the larger one, because when you add a positive and a negative, you want your sum to be negative when you're done. So the larger one has to be the negative of the two. So for example, I'll show you some problems where that works. So this one, I have a negative C, negative 20, which means I'm going to have one positive factor and one negative factor. Because 8 is negative, it has to add up to negative 8 in the middle. That means that my larger factor will be the negative 1. So multiplies to negative 20 and adds up to negative 8. That's going to be negative 10 times 2. So I'm going to put the negative 2 and the 10. So if you're just thinking about factors of 20, 1 and 20, 2 and 10, 4 and 5. You're finding the two that will make 8. And then the 10 had to be negative, and the 2 is positive because it adds up to negative 8. So the bigger one had to be the negative one, the 10. All right, in this one, I have a positive C value plus 50, but it adds up to a negative 15 in the middle, which tells me that they both have to be negative. So I have to find two numbers that are both negative, multiplies to positive 50, but adds up to negative 15. So that'd be negative 5 times negative 10. So it'd be x minus 5 and x minus 10 for my factors. All right, this one's negative at the end, but adds up to a positive number. So you're going to have one positive and one negative factor. Since you're looking at factors of 16, 1 and 16, 2 and 8, 4 and 4, I can use 2 and 8 to make 6, but I want it to be a positive 6, so the 8 is the positive one. The bigger one's going to be positive, and then 2 is going to be the negative one, because 8 minus 2 in the middle would give me 6. But 8 times negative 2 on the end gives you negative 16. All right, and the last one, it's positive in the middle, so you're going to have two positive ones. Multiplies to 6, adds up to 5. You could either do 1 and 6 or 2 and 3. You have to use 2 and 3, and they're going to both be positive. So x plus 2 and x plus 3. So when a equals 1, you're just looking for numbers that multiply to the last number and add up to the middle number. It does get a little bit more complicated, but these are the easy ones, and this is where it is just x squared. So practice these so that you are more familiar with the process, so then we can do some harder ones tomorrow. We have the special patterns here. So if you think about this is x squared, there's 0 x's, and then minus 25. So if you think about it in the way that we've been doing it, we have a negative 25 at the end, which means we're going to need one positive and one negative, but it adds up to 0 in the middle. So what factors of 25 would add up to 0? Well, 1 and 25, 5 and 5 make 25, and that's what we're going to use. So 1 has to be positive and 1 has to be negative. So we're adding up to 0 in the middle. So x plus 5 and x minus 5. Same over here, we have just an x squared, but we have a minus 4. So what multiplies to 4 but adds up to 0 in the middle? It would be a positive 2 and then a negative 2. We get x times x is x squared, 2 times negative 2 is negative 4. And then in the middle, so x times x is x squared, 2 and negative 2 is negative 4. And then we get a negative 2x and a positive 2x in the middle. So those add up to 0. So this is special patterns of difference of perfect squares. So anytime you have, a squared minus b squared, it factors to a minus b and a plus b. So our first and our last term are both perfect squares, and there's subtraction in the middle. Then it will factor to, x squared is x times x, and 25 is 5 times 5, and then you have one positive and one negative. So that works every time. This follows this form. If your terms are both perfect squares and you're subtracting, so a squared minus b squared. So my last one is y squared minus x squared. They're both perfect squares. Y squared and x squared would be y plus x, and a y minus x would be that factor. So just practicing that a couple more times. 11 is a perfect square. It's 11 times 11, so 11x squared would be 11x. 16 is a perfect square. You're subtracting, so it's going to be 11x minus 4 and 11x plus 4. You can put them in any order. Could have been 11x plus 4 times 11x minus 4, because multiplication is commutative. We already did this one. 4x squared minus 9. 4 and 9 are both perfect squares. 4 is 2 and 2. 9 is 3 and 3. So it'd be 2x plus 3 and 2x minus 3 for these factors. So it is both perfect squares, subtraction, and the middle term is 0. So then that's the special pattern, a squared plus b squared. X squared minus 9, it'd be x and x, and then negative 9 is positive 3 and negative 3 in any order. All right, that's factoring day 1. It will be a little bit more challenging tomorrow, but I wanted to start out with just practicing the factors. So if you need a multiplication chart, download one, or use one that I have, and that will help you come up with like the factors of the last numbers, like the 16th, so to make factor lists.